Hello, I'm going to briefly cover some of the advantages of Jennic audio solutions and how they might fit your application. Why another audio? There's lots of audio systems out there and proprietary 900 megahertz Bluetooth. They all have traction and they all have certain market segments they're good for. The Jennic audio solution is based on an IEEE 802.15.4 radio, which has a lot of benefits that these other technologies do not offer. When you're doing audio designs, retransmission is an issue. The packets have to be ordered and they have to be isochronous. The timing is very, very critical. You cannot retransmit packets and have them be out of order. What we've done with our reference design is done a isochronous design for a given application, in this case the audio application, and it gives you a very good performance and keeps the packets ordered. Some of the other factors that are important are whether you're going to do mono or stereo. If you're going to do stereo and allow retransmitting, there is not enough bandwidth on a 15.4 radio, even if you do MP3 encryption. So our design is typically based for mono audio, which is great for tone quality audio, but if you want to transmit music in stereo quality, this is not the wireless radio scheme for you to use, but if you want high quality, tone quality audio, this is a great solution to use. A brief comparison between all of the technologies. Bluetooth certainly has a fit for stereo audio. It also has a good fit for other applications, including cell phones and so forth, but some of the disadvantages it has, if you see on the chart, is a maximum number of users. Because Bluetooth is hopping between channels, if you have 4 users in close proximity, that's about maximum you can support. A 15.4 scheme from Jennic can support at least 10 users on one channel, and then let alone you have multiple channels to be supported. Bluetooth also is not a secure audio transmission. The Jennic system can be based on 128-bit encryption, so you have a very secure audio channel that can be used. Software programming is easy to use. Another benefit is that the power consumption is very, very low on a 15.4 radio versus any of the other techniques. Ideal applications, again, it's not going to be fit for stereo audio or cell phone applications unless they already have the 15.4 chip in it. The applications that we see as a fit would be safety, fire, door entry, those type of communications. The cost is also very low. Power consumption is very low. Some of the bandwidth that's required, so what we feel you can do is a full duplex tone quality audio on our system. We use intelligent frequency agility, which means we can hop between channels if noise is detected. We're constantly scanning in the background for clear channel authentication. If a channel gets busy, we would automatically switch all the users to a different channel on the radio. PTT is push-to-talk. That would be more of an intercom system where you push it and then that initiates a talk conversation. It can be initiated from either endpoint. That is supported by our system. Volume control can be done, test tones, and so forth. And it shows you roughly the sampling rate and what can be supported on the chips. Besides doing the audio, there is a serial output which provides some diagnostic capability. It's showing you the real-time data, how much is being transmitted, what channel is being used. So this could be used, another application could be scanning it and determining just how good your audio quality is, or most users typically use this only when they're testing or deploying the radios, and then they would not use this feature or turn it off when it's actually being used in a product in production. The intelligent frequency agility that allows you, the dot shows you what channel you're on, and you could start to turn on Wi-Fi routers or other type of interferences and see that the channel would switch to a different clear channel that does not have as much interference. This next slide shows you with animation exactly how our system works. It is based on a hopping scheme so that the first radio, number 1, transmits its audio information. Receiver 2 receives it and retransmits it, so all users then see it within its radio sphere. They see all of the data and so forth, and it continues hopping. We feel you can get good audio quality with 5 to 6 audio hops. It will not run on a Zigbee or GenNet network. It's strictly on a 15.4 software stack, which is okay because we support that. We support GenNet, Zigbee, or 15.4 radio stacks on our devices. It is important to know about delays and how much it takes a delay. Otherwise, you'll notice an audio delay. Certainly, if you want to go above our recommended 5 to 6 audio hops, you can do that, but you would notice a audio delay in your transmission. And that's one of the reasons why we don't run on a network. We recommend that you do only 15.4 radios, and it is ideal for police, fire, intercom type systems. This slide shows you why it's ideal for different type of users. We have the application would be if you had people inside of a building and they have their long-range radio, even though they're in close proximity to each other, they have to transmit. This radio signal has to get out of the building, go to some kind of antenna, and then come back into the building. With the Jennic radio, the signal hops from user to user, and it does not have to get out of the building, and it's therefore we can coexist long-range radio with the short-range radio from Jennic. Here is showing a system on what we could be used for intercom systems. You could push a button to initiate the push-to-talk, and the signal would hop around inside the building to another user. The advantage to it is that you do not have to run any data cables. You may want to run a power cable to this intercom system, but you would not have to run any kind of data cable. You could easily move this wireless intercom or the speaker on the inside to any location, and the signal would hop to get there. Our audio reference design uses an external DAC. The recommendation for that was we wanted high-quality, tone-quality audio to be present. If you certainly could use the onboard A to D converter, you probably won't get tone-quality audio, but if all you wanted was walkie-talkie grade communication, you could use the 12-bit SAR A to D converter that is on the Jennic radio chip. We give a complete design, schematics, plug-on board. So you see the part number for JN5139.XK001. That's the kit that you plug on. You get 2 boards. It costs around $300. You get complete hardware reference design, software manual, source code, everything that you need. In fact, the source code is on the Jennic web to get started, along with the schematics. So you would get that all in one nice kit. And you can do a line in or microphone and speaker on separate jacks. Thank you very much for listening. Any questions, feel free to contact Jennic.